My name is Aaron Trost, and our group is the Enzymatic Beer Group.
I'm Andrew Furrow.
I'm John Rossell.
I'm Molly Sheard.
Our group focused on making enzymatic beer. Basically, beer is the most popular alcoholic beverage in the United States. Expect to grow 19% from 2010 to 2015. Right now, the traditional beer process is taking grain, adding it to hot water with malt, and taking the sugars out of that grain as food for yeast. And the yeast eat that sugar and produce alcohol, which is then in the beer. What our process is we take out the malt and we replace it with enzymes. What malt does is it's basically a natural enzyme to break the sugars down into smaller pieces for the yeast to use. However, malt is an expensive process to partially germinate the malt and get the enzymes extracted out to use in the beer making process. What we're going to do is use what's called alpha amylase and glucoamylase, which is an enzyme derived from fungus, to break that sugar down for us instead of the malt. And it is a more cost-effective way of breaking those sugars down in order to make the alcohol.
And not only changing the process in that way, we also wanted to consider energy consumption. So something that we chose to do was make two heat exchangers, and you can see here, here's our process, and we have a heat exchanger here and a heat exchanger here. And basically all that does is we're recycling energy from our hot liquid, and we're transferring it over to heat up our cool liquid. And what we found is that we can save about $10,000 a year by implementing this process.
I think the biggest technical challenge would probably be getting everything nailed down to specifics. The temperature that we need to get the enzyme to work at its greatest potential, the amount of enzyme we add so that enzyme isn't inhibiting each other, and how much time we use to break down the sugars and let the enzymes work. Getting those three to coincide and work so that the enzyme can work at its greatest potential and get the greatest amount of sugars is the hardest part of this. We ran 3 experiments. As you can see, the alcohol by volume is low, and what we think that is our temperature was too low and maybe we didn't leave it in for long enough, so the enzyme we didn't get as many fermentable sugars out of the oats as we possibly could have. And Molly can go into more detail about the actual experiments that we ran.
Yeah, so we heated the water and made the starches come out of we used oats for our grains, filtered it and added, like Aaron said, varying amounts of enzymes. And then what you do is, once the enzymes are in there, they're going to take the starches to sugars. And so we let them do that at kind of a lower temperature. And then you cool and measure the specific gravity of your mixture. And then from that we can calculate how much alcohol would have been fermented.